All right, so let's move that on camera. So this is what we looked at in the first video. I saw this week. So the success rate of vaccines at this stage of development is 10%, Shattuck says, and there are already probably 10 vaccines in clinical trials, so that means we'll definitely have one. So you identified that this might not be true, right? Mm-hmm. And so we were computing here. In fact, you said it. What's the number we need to compute the answer to here?
9 probability of not getting one that works is 9/10 to the 10th.
Yeah. So 0.9 to the 10th power. And let's see if we can connect this up with E. So what did we learn about E in the last video?
I could say that E is approximately 1 plus x to the 1 over x.
Okay, so E, we learned E was approximately 1 plus x to the 1 over x if x is small.
Mm-hmm.
Okay.
So maybe, could we say x is negative 0.1 here?
Okay.
I guess then
here.
x would be small.
Okay, well, yeah, absolute value of x is small, but still. Yeah, so if we say x is 0.1 here, sorry, negative 0.1.
So that becomes E is 0.9 to the
E is approximately 0.9 to the
negative 10.
negative 10. So what is this number going to then be approximately?
So it's approximately 1 over E.
Yeah, because we have a negative power here for E. And if I make a negative power, I can make a negative power positive by taking
the reciprocal.
the reciprocal. So this should approximately be 1 over E.
Which is, I mean, a rough approximation. Is it 1/3 chance?
Yeah, so we can go back to that scientific calculator again. Sorry, I'm having a hard time. Why am I having a hard time doing e to the minus 1? So can you do e to the minus 1 for me?
I don't know how I have to do.
Plus or minus,
minus
yeah,
1.
and then e. Sorry. 0.3, 0.36, call it 36.8%.
Mm-hmm. So I mean, that's roughly 1/3 chance you're not going to have, in this case, you're not going to have a vaccine.
And let's do 0.9 to the 10th.
Point 34.
34.9%. And I should say that the math we're doing is making a couple of very critical simplifying assumptions, that all the vaccines are independent, that their chance of success looks like all the chance in the past, and all that kind of stuff. But I want to take this problem and those simplifications as an example of this fact with E.
Yeah.
So it's really a surprise that the surprise here is not only is the statement here just not true. If you take 10 shots at something that has a 1/10 chance, you're not always going to get it, as you pointed out. If you roll a 10-sided die 10 times, you're not always going to see every number.
In fact, you probably won't.
Right. The surprise is that you can actually calculate this number, the approximation for this number, in a snap, as long as it's close to 1.
Mm-hmm.
It's about 1 over E. So in fact, you'll see, if you roll a 10-sided dice 10 times, you should expect to see 10 times 1 over E of the numbers.
Yeah.
Now, by the way, do you believe this? Do you believe that 0.99 to the 100th power is about 1 over E? In other words, that 0.9 to the 10th and 0.99 to the 100th are about the same number?
Makes sense.
Yeah, it should make sense.
Just try it. Let's see what the calculator says.
0.99 to the 100. Yeah.
Yep.
Wow.
36.6.
So It's amazing that this calculation is independent of n as long as, well, essentially as long as n is large or 1/n is small.
Yeah.
Cool, huh?
Yeah.
Really cool.
There's 3 different ideas about E that came up just this week.
Yeah.
Wild, huh?
Yeah.